presentation is Geo-Tagging Aerial System.
Ladies and gentlemen, my name is Maximo Konenko. These are my colleagues, Kenneth Johnson, Ben Stevens, and Michael Baker. We were tasked with the UAV vision goal. Basically, we had to design a system that would be the eyes and ears and sensors on a UAV, and it had to be applicable to a multitude of UAVs. Furthermore, we had the restriction of using these GigE cameras, and as always, power is at a premium, and so is size and space. This is our solution to the problem. We called it the Geotagging Aerial System. It's basically a combination of sensors and cameras that we control, and part of the design was included in the ability to take the system and implement it in a variety of situations on a variety of aircraft. Our possible uses include storm chasing, photogrammetry. There apparently is interest in keeping track of cattle or monitoring pipelines for leaks. Pretty much anything that you can monitor from the air, you could integrate into this system. We have two distinctive hardware packages. The first is an Arduino-based package that monitors and implements all of our sensors. Currently, we have a GPS and IMU and a radiation sensor hooked into it. But because it's serial-based, we can implement just about anything that could be useful. The trick behind this is the main Arduino board takes the information from all of the sensors and combines them into a single text file. It can then either store the information onto an SD card that's on the Arduino board or output it through the Ethernet. And of course, it can also do both. The second primary hardware package is a Digilent Atlys prototyping board. We selected this because of several reasons. The first, of course, is its size. At 5x5, it was the smallest and cheapest prototyping board that we could find that also met our second requirement, which was it had to have a GigE port on it to integrate with these cameras. The purpose of this board is to take the information from the Arduino as well as the images from the cameras and move them over and store them on either an SSD or a large capacity SD card. Basically, this is your main brain for the entire system, allowing the end user, when the aircraft returns, to simply remove an SSD or remove an SD card and take it to a computer for post-processing. This board runs an embedded version of Linux called Petalinux. As far as challenges, this was our greatest challenge and continues to be our greatest challenge, is working with this system. And going forward, it will be one of the main areas of development for us. Our future plans for the Arduino, we hope to integrate a humidity, airspeed, and barometric pressure sensor at a minimum. Also, we are looking at implementing other sensors as people come out of the woodwork and are looking for help with various projects. As far as the Digilent board is concerned, we've continued working on the Linux and investigate other uses. Also, we'd like to implement more than just one camera with the board. I'd now like to open it to questions.
What type of video is coming out of that camera? Is it compressed? Is it raw?
The cameras actually have the ability to provide compression. However, because of the photogrammetry environment, we're probably looking at raw video coming out of those cameras.
So on the interface, like on the GPS, is that just a straight RS-232? But like you got GPS and the camera. I mean, physically, the hardware that you're getting the data into. How is that done?
So physically, there's two sets of boards. The first is the Arduino setup, which you can kind of see right here, and that the GPS goes into the Arduino board.
I'll field that one. The GPS module that we're using outputs the standard NMEA sentences, and the Arduino processes those sentences, or parses them, and sends it all up to the rest of the system.
Eventually, those two channels get into this embedded processor, and then from that processor, you send out that information gigabit Ethernet.
To a storage device, yeah.
And then Linux is giving you the GigE stack, whatever that you need to use to.
Yeah, Linux is running on the main board. Basically, it just pulls the data as fast as it can from the cameras, and then it takes a text file, and since they're all time-stamped together, you can do any number of post-processing on some real hardware when you get back to the ground. Any further questions?
Who's making the, you're trying to integrate this onto the existing robotic system, so you said that you're required to use a GigE camera. Who's imposing that requirement on?
The professor that we're working with, and part of the idea behind that requirement, it's not an arbitrary requirement, because of the high data transfer rate that's possible, and because of the large amount of information. Like this camera right here is a low resolution camera, but it operates at 90 frames per second. So we also have a much higher resolution camera that operates 15 frames per second, and we have an infrared camera that's available to us as well. And the final goal would be to have all three of them, and the only way we can manage that much information is through the GigE protocol. Yes.
So this is meant for aerial type capture, so quite often you typically have occlusion there, a bird flying or something flying in front of them. So how do you have some design specs in terms of if you have something that you can't see in the image because of occlusion, you're able to rely on something else?
Well, the idea is, so you can see the helicopter there, and there's a camera mount right in front of it, and the flight time on these things is something like 20 to 30 minutes. So the ones that we're building for specifically are relatively short. Unfortunately, I mean, we don't have anything built in, neither does the helicopter. If a bird flies into it, then unfortunately that you have to
I'm not saying
redo it.
flying into it, I'm saying flying in the path where the image is actually going.
Unfortunately, this time we don't have, there was some discussion of having a wireless system that would transmit a very slow frame rate back to the operator. But these also, as I think another team or a professional is being brought in to do this, but these are going to have autopilots, meaning that they go up, they run a specific pattern, and then they come down. And if the image is disrupted or lost based on environmental conditions, then that's something that has to be adapted for on the spot. It's not included in our program.
Well, thank you.